So in this video, I want to show a real-life example of graph convolution. And so I'm going to take all the code here from this blog post on this wonderful blog. And so it uses first of all, it uses a neural network library called PyTorch that's already on Google Colab. It's something similar to Keras and TensorFlow. But we need an additional package to handle the graph convolution, and that's called PyTorch Geometric. So let's start by installing that. So I've made this notebook here. I'm going to give a link to the notebook that you then can use as a starting point. So the first thing I'm going to do is go in here and save a copy in Drive. Right, so that's what I'm going to work with, and I'm going to call this graph convolutional neural net example. Okay, so let's start by installing this. This is actually going to take quite some time, so you have to be a little bit patient. I think about 5 or 10 minutes worth. Okay, so let's make a new section here for our code. Get rid of that, add a code cell, and let's go grab some stuff. So there's actually two chunks of code here, right? So one is what in the end is Multivec, right? And then here is the machine learning code. He has saved this as a file called Multigraph, actually. So that's what all this is. Interestingly, most of this code, as he says here, is borrowed from DeepChem, which I'll also make some videos about. So this is also, you can sort of see under the hood here what DeepChem does. But okay, let's grab this. And actually, so a better name for this section would actually be Multigraph, like this. And then we'll paste everything in here. And then we can add another section here for the actual, what I would call the code or the machine learning bit. And we don't need that percent thing. It doesn't really hurt if you have it here or not. So this comes in several chunks. Whoops. Let's see how I can select that. So let's put this in one cell. Oops, this is a little tricky. Grab this. Grab this. And yeah, this is the last bit. And so if all this works, we should see something like this once we run it. Okay, so let's go up here and start running some cells. Okay, that worked. Let's see here. Oh, right, so this is, we don't need this. That's the code that we added above. Okay, so I think this is probably something with Google Colab. So one option here is to see if we can find this. This must be somewhere on the RDKit site. So I'm going to search for this. Yes, here it is. Okay, so I can use wget to get this. So I'm going to add that up here. So wget, and we need both the training set and what's the other thing is called the test set. So let's get those. Let's try this again. Okay, so it read it in. So this is, yeah, so it's training on solubility. It's a categorical classification. So basically the data has been divided into low, medium, and high solubility. And so that's what we're trying to predict. Let's see. Mol to graph. Yes, so this is just, we have the mol to vec function above. So we don't have to worry about that. So we can remove that. Did I get everything? Yes. And so here, this is how you define these things in PyTorch. Let's just make sure it runs first before we get too excited. And here we're now, you can see we're now training. And here is where we define the number of epochs. So let's just run it first. That runs. And let's see, it's thinking. Okay, so now we're training. Excellent. So this is going to work. Okay, so you can see the training and test accuracy here, and so that looks pretty similar to the blog post. Let's go down here at the bottom. Of course, the weights are initialized randomly, so we'll get something slightly different. Okay, so you can, let's go up and look at, so here is where you define the architecture, right? So you can see we use a graph convolutional neural net here with this many features. And the number of features is 75. We'll look at that some more. And you can see after batch normalization, we do the convolution twice, and then we fit it into a set of linear layers. And so this function right here, right, that's the graph convolution. If we go over to the PyTorch geometric manual, you can see that this is exactly the equation I was talking about in the previous intro video to graph convolution. So here are the features and the weights. Excellent. So the last thing I just want to show here is some of the features. Right, so we have, if I go down here, so we can see we have some atom features that is put on each node, right? So actually, let's see what those look like. So print node F, and so I'm just going to do it for a simple molecule. So mol2vec, and so let me make a molecule from smiles, like so. I forgot to run this. Okay, and so here we're printing out the node feature. And so as you can see here, it's a a one-hot encoded string for the carbon atom and for the nitrogen atom, right? And so you can see, for example, here it starts 1, 0, here it starts 0, 1. And so if we go up here in the list, we see that indeed carbon is first on the list, nitrogen is second on the list. And similarly, we have things like hybridization, number of radical electrons, implicit valence, and things like that. So for example, I think if I go down here, so you can also see at the end here that the carbon and the nitrogen is at the very end here is differently one-hot encoded. Right here, the string ends with 0, 1, 0. Here it ends with 1, 0, 0. Right, and so the last feature that's being added is the total number of hydrogen atoms. Right, where carbon will have 3 and nitrogen will have 2 hydrogens. So this is exactly the kind of thing I demonstrated here as the one-hot encoding. So that's graph convolutional networks working on an actual example.